Thank you all for joining our session, Supercharge Backstage, self-service GitOps staging environments using vCluster and FluxCD. Right. Before we begin, just a quick show of hands. How many of you are aware about Backstage? Okay, and how many of us have worked with vCluster or know about it? Cool. And how many of us has adopted GitOps or worked with Argo or Flux? Cool, yeah, so very exciting. Then you will all be able to grasp whatever we are going to explain very easily. We have kept it as simple as possible, so yeah. And quickly moving to our agenda. So it's just straightforward, right? We start with the problem, what was holding us back, and then we have the solution, like how did we fix it? And then we'll see the impact it had. So once we have the solution implemented, what all it improved in our organization. And at the end will be the next step, like from here, how we as a community can take this forward, right? So that is covered. We move next. So before we begin, a quick introduction about us. So my name is Farhaan. I have around 8 years of experience in cloud native technologies, currently working as senior DevOps engineer at Siemens. And recently, I've started working with Backstage, vCluster, and FluxCD, right? Along with me, I have my colleague Rakesh here.
Hello, I have around 8 years of experience in Kubernetes and development. Yeah, that's good.
Cool. So you can trust us. So we have been working on this, and whatever solution we are showing, it'll work out. So no need to worry about that. Yeah. So okay, moving on to the first point on our agenda, the problem, right? So what we, as a team, also faced this, and when we discuss with other team, also we have faced this. So we will take this solution through a developer's point of view, right? And then at the first, we are seeing what are the developers paying today, right? So to start with, let's assume we have a developer who has a feature which they want to test it out, and then they need an environment which is running on Kubernetes, and it's like a production, right? Now, just to create this environment, currently what they would have to do is they would have to contact the infra team, right? And the infra team will and ask them to create an infrastructure for them, right, to create this environment. And for that, they will have to raise a ticket. That ticket might go to some approval, right? And then they will all again have to wait for the infra team's availability to provision this one. Yeah, you can also say, why can't we use automated pipelines and stuff, right? But still, it goes through a set of approvals, right? And then at the end, they again have to go back, like once their testing is complete, they again have to go back to the infra team and tell them, okay, my testing is complete, please destroy it, right? So this they have to do just to test out a feature which they have just developed, and they could have just done it easily on their own system also, right? Just for an environment, they had to go through this whole process, right? So that is where we thought, like, why is there this dependency between a developer and an infra team? Why a developer can't create this environment on his own? Why they have to wait for another team to provision it for them, right? And we thought, okay, what if the developer could create a fully isolated environment just with a click? So a click here refers to an action. It can be a git commit, it can be a merge request, anything. So that is what we are trying to show, right? And so keeping those challenges in mind, quick intro about this talks, like why this talk matter. So this staging systems which we are trying to see, these environments which I was trying to show. So these are shared, so these are slow, right? And then it also increases the cost of maintaining this whole system. And then there is a manual step of creating this system and provisioning these environments, and that is a very huge blocker for you, right? For the developer also, he has to wait. And then if you would have automated all of this, the provisioning of the environment itself, if it's automated, then nobody needs to wait for anyone, right? And then you save upon cost that we are going to show how we are doing that, right? And then you have very less delays, right? And out of this whole showcase, what you will learn is how you use this self-service portal to create the environments, and then how you give this developer their own isolated environment, so it's not conflicted with some other developers' testing, right? And how do you keep your testing stages in sync with Git, so that the Git is the single source of truth for your whole environment? And we are trying to provide you a blueprint. So whatever we have used, we are trying to give you a blueprint. You can adjust it according to your needs and change whatever tech stack we have used according to whatever suits you best, right? So moving on. it's also important to discuss what we will not be covering in this. So this is not a tutorial, right? We won't be going through the step-by-step implementation of all these tools. We'll not be explaining the technology or the concept behind these tools. Like, I can't be explaining how GitOps work in 30 minutes, right? So that is there. We are focusing on the practical strategies, like how we have implemented it and then how we have used it, right? Moving on. So circling back to the challenges, the core challenges which we had talked about, and when we are creating this environment, what are more challenges you can face when you create this environment, right? So first of all, these are shared, right? So one team is testing out some feature on an environment can definitely conflict with another team if they are all, again, going to use the same environment, right? And then maintenance. So the infra team, again, has to maintain the staging, this QA, pre-prod, and all this overhead cost is adding up to the maintenance. And again, the dependency which we talked earlier. So developer is again waiting for the infra team that please provision infra for me, I'm waiting for this and all. And at the end, you also have a different kind of environment. So maybe environment was created for a local on a server, right? And then developer tested out there. Now your next staging environment is on EKS, and then the whole Kubernetes stack is different there, right? So what might have worked on a server might not work on an EKS cluster, right? So you have the different configuration there, and at the end, the developers say, hey, it worked on my machine. I don't know why it's not working here, right? And then the circle goes again. You are going to change that again, right? So with that in mind, we moved to the next point on our agenda, which was the solution, like what we came up with. So in Siemens, we came up with this thing called dynamic staging system, where our vision was that we could create a GitOps-powered platform that will enable an on-demand ephemeral fully isolated staging environments that will be per feature branch and with zero manual intervention. So there will be no manual intervention, it will be fully automated, right? And what will be the key principle behind this whole setup which we are trying to show is, first, self-service, right? So the developer has the whole control over it. They want to create an environment, they can just log in, create an environment, destroy it out, ephemeral. So each developer will get their own instance of the environment, right? There will be no more conflicts, no more waiting for another team to test, finish their testing and all those things. GitOps native, so that your single source of truth is Git. Whatever is pushed to Git, that is available on your environment. You can change it back. Once it's committed, that is available. You have all the history also. So next time you want to see which environment was created using which commit, you can go back, use the same commit, push it again, and you have the environment. You can see out, okay, what was created using that commit. So that is what the reusable patterns at the end, right? And moving on. So to achieve this solution, we have used a certain tools here. And then I will reiterate again, this is just a blueprint. So this tool stack fulfilled our needs. It can be different for you. Maybe you want a UI, right? So FluxCD won't fulfill that for you. Argo CD is the best case for that, right? So you can change this whole tech stack, use whatever tool which you seem perfect, and then use this blueprint, right? So to start with, we have used Backstage as a self-service interface. So Backstage has a UI where you fill up a form, give the data. That data goes back to the plugin at the backend. It runs some logic on that, processes it, and forwards it to the next component. And for the GitOps management, we had used FluxCD so that it has the different controllers. You have source controller, customization controller, which will be looking at your Git commits and then creating those in your environments, right? And then for ephemeral environments, we had used vCluster. So vCluster spins up a Kubernetes cluster very quickly with minimal efforts, right? So that was the reason we used vCluster in that. So these three were the basic building blocks of this solution. And on top of this, to ease the access, we had used kubevilla. So kubevilla is an abstraction layer on top of Kubernetes, so that if your developers who are not very much familiar with Kubernetes can skip the part where they just easily use kubevilla and then interact with the Kubernetes resources. They don't have to learn about Kubernetes and all those stuff, right? And then there is a tool copier here. So this is being used very heavily in our solution. So it's a questionnaire-based project templating tool. It will ask you some questions, which you would have, the template creator would have created. You answer those questions, it will create a project template for you. And it is a very awesome tool. I will request you, everyone, please check this out. And then if you see it fulfills your need, you can definitely use it. Or if you have any issues, please raise it. We have a team at Siemens which is maintaining this fund, so we'll be happy to help you. And at the end, we have used Carpenter for auto-scaling because this ephemeral storage, it's so easy to create them. There will be many of them, right? And your cluster needs a scaling system. And in our use case, there were ML workloads, there were workloads which need GPU. So we needed something who can create GPU-based nodes for us. So that is the reason we had used Carpenter for us, right? So yeah, this was the tools and technologies. And moving on to the actual architecture of this solution, right? As I mentioned earlier, we have at the foundation, we have Backstage, we have GitLab, and then we have Kubernetes. And then in the Backstage, you have a UI form template where you fill up the data inside a UI form, right? And then it processes it, gives it back to the backend, which is a plugin, and then the plugin processes it and runs the logic which you have implemented, right? So here comes the first actor, which is admin. So the admin will be someone who will come on the Backstage and say that, okay, I have a team of 10 developers. I want to create a cluster, and so that these developers can create their test environment on top of that cluster. So keeping that in mind, the admin will log into Backstage, right? Fills up the form, gives the data. That data is being processed by the plugin, and then it will be forwarded to Copier. Copier will process it and create a template for you in the GitLab. So that will be, we'll call that as host.git because it is acting as a host cluster for you, right? And then after that, the Flux will be monitoring that source controller, right? And then it will create the resources into the Kubernetes for you. So, and this was the one-time activity which an admin has to do. And after that, there is no dependency between a developer and the admin. This was the only task of admin. There is no maintenance or anything, something like that they have to do on top of it. Now comes the developer. So the developer is the second actor who says that, okay, I have a feature which I want to test. I need an environment, right? So again, they log into Backstage, fill the form. The data gets processed by the plugin, goes to Copier. The Copier creates a vCluster.git for them. This is just a repository which they have created. Now the developer says that, okay, I have a repository where my feature which I have developed is there. Now I want an environment which can deploy this. So they again come to log into Backstage, fill up the form, give the data about the host cluster. So they say that, okay, I have a cluster which my admin had created. I want to use that and create an environment which should have the feature which I have just created. So they fill up the last form, right? And then it goes to the Backstage, plug backend, and the plugin processes it, forwards it to Copier. Copier create a vCluster.yaml file in the host.git, which admin had created. And this is just a pointer to the vCluster, which the developer had created. So now the Flux sees that, okay, there is a change in my source. I have to deploy something into the cluster. So it creates the resources which were requested in the Kubernetes. And in our case, that is a vCluster. So Flux will deploy the vCluster, and then it will also, as it is already pointing to vCluster.git, so whatever resources were requested in that vCluster will get deployed onto the cluster. Same thing, a new developer comes in, they will also say, I need an environment, right? So again, they use the plugin, goes to the GitLab, create vCluster.git. They say, okay, I want an environment of that feature. They again run the plugin, goes to GitLab, create vCluster.camel. Flux will be monitoring that, and that will create the vCluster for them. And the resources are deployed on the Kubernetes, right? So yeah, this was the architecture which we for the solution use case. And then I will be handing over to Rakesh here, who will be showing us the whole demo, how end-to-end these things are working, and we'll see then afterwards. Yeah, thank you.
Thank you, Farhaan. Thank you, Farhaan. So we'll continue with the demo flow here. So what is the scenario is like this developer comes into the picture and he want to test the feature where in a production like environment with a complete isolation. So the flow is like a developer comes and access the Backstage. He starts creating the Git repositories. Then those Git repositories have access to the Kubernetes using the GitOps, then Flux Bootstrap, those environments, and the developer access those environments, start deploying the applications into the newly created environments. So I'll just open the video. Yeah, so this is the Backstage, which is hosted in my local environment. We have enabled the GitLab authentication for the signing in. Once we have sign in, the admin gets into the Backstage and start creating the domain and the host file. So here what we're seeing is the templates which will help this scenario to process out. The first one is a create domain, which helps you to create the GitLab group for the isolation. The second one is a create system, which helps you to create the host.git and a vCluster.git. Third one is like a put the vCluster file into the host.git. So let's continue. So we'll check here, create domain. Here we are entering the GitLab group name and the description of the group, and we'll provide the owner information. The owner information is required for the RBAC for the future. So let's review this information and create it. Once the GitLab is created, we can review it. So here, the first one is like checking the GitLab group is present already in the GitLab or not. Second one is like pushing the new GitLab. And the third one is like using the copier, we are pushing the scaffold templates as a skeleton. The third one is creating a GitLab project with the same name as group. We want to register that back to the Backstage. So this is the workflow steps here. Yeah, let's see the repository. So the developer comes back and starts creating the system here. This is the system where it requires the project name and the description of the project and the cluster name, cluster type. The cluster type can be local, Azure, or AWS based on the option which you have selected. The fields will change dynamically. So for example, in local, we don't have anything. In AWS, we need an account ID and the credentials. Then we'll proceed further. Yeah, you can see the dynamic template revision. So here what we are doing is like in the previous page, we are selecting the group which we have created for the isolation, and we review the information and we start creating it. So these are the workflow steps. What we are doing for the fetch is like we are fetching the group information. Second one is like what are the information I have entered in the Backstage form. Those information is fetched and passed to the copier. Copier sees it and publishes a outcome that will be published to your GitLab. Then we are creating a GitLab token that is used in your CI/CD operations. And the fifth one is like we are adding renovate bot in our GitLab repository for the future updates, and we are registering back this component to the Backstage. So once we register, here the administrator role is completed. Now the developer goes back to the Backstage and logs in, and he do the same process for the vCluster.git to be available in the GitLab group. So once he do the process, we have the vCluster Git in the GitLab. We have selected the same domain. So the steps remains the same for the developer as well. Yeah, now we have both repositories. Now we want to attach the vCluster to the host cluster. So what we will do is we will go to the template and we'll choose the host cluster system and the vCluster system. We'll review this information and we'll go to the next to configure the vCluster configuration. Here we are entering the vCluster name and the namespace, enable autoboard, which helps you to copy the credentials like SSH key, which need to be accessed, the Git repository from host cluster to vCluster, and few more information which is required to configure this. So here you can also give the branch name of the vCluster, and in the next page you can also have the branch of the host cluster as well. So here we'll review this information and we'll just create it. So here the steps are important. Like first thing, we are fetching the host cluster.git project, and we are running the copier update where it takes the vCluster file and runs the copier update and pushes to the host cluster.git. Yeah. Now this information is ready. We can see the linking here, like what my domain have. These are the systems I have created in under my domain. So, and you can see the components as well, like an IAM and other things. And here, this is my vCluster. You can see the vCluster resource here. Now let's go to the system, and in the system you can see the information like GitLab pipelines and other things, and you can see the relation as well. Let's open the KNS here and see the workload of my locally deployed cluster. I have deployed this cluster using the DevBox, which helps me to bootstrap a K3D cluster. On top of that, it also deploys my vCluster using the vCluster.yaml. So this is my vCluster namespace. In the namespace, you can see all my Flux and the Kubella and other things. So sooner we'll see the key clock and the pod info as my sample application. Will be accessing the sample application in the browser using the Kong ingress. Yeah, so you can see the key clock over here and the pod info as well. So we'll see the workload of my host cluster as a in a K3D. Let me. Yeah, this is the full load of my host cluster. You can see all the pods which is there in my host, and you can also see the nodes in the previous. So let's access the pod info sample application in my browser. Yeah, this is how easy for a developer to use Backstage and Flux and vCluster to create a fully isolated environment and deploy their application into the vCluster. So let's go to the next one. Yeah, so the real world impact, like our next agenda is like a third point, what we have in our agenda, like the real world impact. These are the areas we had the impact on. The first one is the developer productivity. Like here you can see it takes only less than 2 minutes to deploy a cluster. Earlier we have to take around 45 minutes to deploy an EKS cluster using the Terraform and the pipelines. The second one is a safe testing feature. Like it testing feedback only for, you get it in minutes, not like a whole day or sometime. Like a platform scalability, like the developer comes and start creating as many environments they want. There is no restriction here. The self-service onboarding, like the developer comes, logs in, and start creating the vClusters. Like here also there is no restriction. And the automation and cleanup. So here Flux handles the creation and the deletion using the GitOps, like there is no manual intervention. You delete the branch. Once it is merged, then the deletion is happens automatically. The standardization of environments, here you can create environments at any point using the Git history. For example, let's say I have a branch which was worked in a vCluster at certain time, and later on, once it's merged to the main, it stopped working. Using the branch history, from that commit, I can create a fresh branch, and I can deploy into a new vCluster. So that's how the standardization is. So what the solving problem earlier with our staging system is like before we are using a right shifting. Now we are into a left shift. So in the right shift, developer used to develop the code and deploy into dev, then production, staging, development, then staging, then QA and prod. There are cases where bugs comes up in a prod, which leads to the high risk and slow releases. So our solution is developer test the feature in a production-like environment during the development phase itself, which helps in catching the bugs in very early stage. So the challenges, what we face to bring this solution and how we learn from it. So the first thing is like a complexity of removing the vCluster resources, for example, the ingress, the certificates, and the other things. So for that, we have used the Helm hooks. The second thing is like, as earlier I was mentioned, we need to copy the certain secrets from the host cluster to vCluster to get the Git access. So these things. So how we handled it is like a Kubella workflow steps. The third thing is like a RBAC. Let's say I'm a developer, Farhaan is a developer. So we want an isolation in the Backstage as well. For that, we need to adopt the RBAC in very early stage. And the fourth point is like, let's not make Backstage as a Kubernetes dashboard. So what we want to achieve is like show only the information which is directly relevant to the process, don't make it very complex. So I would like to hand over the closing to Farhaan. Thank you.
Thank you, Rakesh, for the demo. And upon the last point, which Rakesh just discussed, Backstage is not another Kubernetes UI. So when you will be developing this, you will get a lot of requests from non-technical persons to implement this feature, to implement that feature. Backstage can implement those features as well, but yeah, please don't make it complex. So you don't want to see the status of the pod or the status of the endpoint onto the Backstage. No, that is not meant for that, right? It should just solve your problem, and then it should be easy for the developer. The developer should not go and see if your pod is going into crashback loop of what he can do about that, right? He can't do anything about that. So let's keep it simple, or not turn it into another Kubernetes UI. That is what we have learned. Anyone can have any opinion on that also. So closing statement for this, what we have showcased you here is how you can use Backstage, vCluster, and FluxCD to create this self-service GitOps-based environments, right? And this is a proven pattern. So the same pattern can be used for different teams, and they can use the same patterns, use the same tech stack also to deploy the environments, right? And also we have seen the real-world impact, so developer velocity, safety, and lower operational overhead, right? And the key takeaways which we want you to take from this is embrace vCluster. So vCluster is very lightweight, creates a totally isolated Kubernetes cluster you can use, and adopt GitOps as much as possible so that your single source of truth should be Git, and all of the environments, all of your clusters are version controlled. You can just recreate any of the environment from the Git history, from the commit ID. It helps in auditing also, right? And at the end, treat developer experience also as your platform's core product. So we have seen teams always mentioning about user interface, user experience, right? But when we are building a platform using IDP, something like this, you should treat the developer experience also. So we should always try to make it as simple as possible for the developers to use these kind of platform to create these kind of environments, right? Developers should not be spending their time debugging the infra-related things. Why this EC2 instance is not coming up, what is causing this delay? No, they have their own bugs to resolve, so they should be spending their time there. That is not their job to fix these kind of things, right? And yeah, these are a few of the open source tools references which we have used. I will again reiterate, please go through Copier. It is a very useful tool. If it solves your use case, please use it, give it a star. If you have any issues, please feel free to raise it. We have a good team at Siemens which is working on it. And yeah, that will be a thank you from our side. And we are open to questions. If you have any, please feel free to ask them. Yep.
Yeah, so I want to know why you use Copier behind. So Backstage already provides templating and scaffolding, right? And whatever users input is providing, so that can be translated to the template by Backstage itself. So what is the specific use of Copier in here?
Yeah. So the question is like why we used Copier for this project templating, right? So Copier was built for that only. And when we were developing the plugins in the Backstage, translating all those user data and then creating the Git repository out of those user data was too much of a work for us as a platform team, right? You might need a Node.js developer for doing all those stuff. So we saw that there is already a tool which can do this stuff. You just have to provide it in a YAML file. So we said, why not leverage it, right? So it's just like that. Copier is also running inside the Backstage itself. It's not like it's being hosted somewhere else. It's a CLI tool. It's running in the same instance where Backstage is hosted. The data, whatever user gives it to the form, it gets to the plugin. The plugin simply calls the Copier CLI, provides the data, whatever user is given. Copier just creates the repository out of the box. You don't need to have a separate logic for creation of a GitLab repository and the structure of that. So there also we face some issues like how do you structure the files, which file to create. You will have to use external packages to read the files, if it's a Terraform file, if it's a YAML file, and all those things, you have to parse them, right? So there was a lot of overhead for that. So we just use Copier out of the box. It can do that for you. Yeah, sure, we have question here.
Hi.
Sorry, I can't. Yeah, okay, got you.
Yeah, you were telling about self-destruction of that environment, right? Once you delete the branch, then that will be automatically deleted. What if like developers forget to delete that branch? Because that is the common issue we face. Once we give them some resource or environment or something like that, because of their stress or something, they tend to forget that. So in that sense, how will you audit that to make sure it's get deleted? Do you run any checks twice a week or weekly once or anything as such if they tend to forget?
Yeah, definitely. The solution you yourself have mentioned, you can have some checks on amount of time a vCluster is running. You can have the check on that also. And based on that, you can identify, okay, this vCluster has been running for too long, right? I need to delete it. Or what is the reason why it's being running for too long? Or you can simply ask in the morning Scrum call, hey, who has created this commit? Why this vCluster is running? You can ask them to delete. But yeah, definitely, the solution which you have mentioned that, yeah, you can have some custom logic to check the time vCluster is running and you can delete it off directly. Yeah, that is also possible.
Yeah, thank you.
Okay. So first of all, thanks for sharing the insights, what you have built. Yeah, it's really good to know.
Yeah, thank you.
And one thing I would like to understand, maybe if you can share the onboarding experience of your developers and specifically the new developers which join the organization, how they feel, and if you can touch upon the challenges they face. That's point one. Another is you are sharing that initially they, as a developer, they have to fill the form and give some inputs. Can it be something self-serviced or automated? I'm not sure why you kept it. Maybe if you have some plans, just so that it would be abstract for the developers. They should not do any manual intervention. It would be automatically running as self-servicing. So if you can share those inputs on that part.
Yeah. So regarding the first point, the experience of the developer, so we have already deployed this in a few of our teams, right? And then the developers are finding it quite easy rather than contacting the infra team and telling about their requirements that sometimes the developer themselves don't know what kind of node I want, right? They just know my application is this. They don't know how much RAM it will require, right? Sometimes that is also the case, especially with the fresh new developers, right? So this is solving that use case very efficiently. They just have to fill out a form. And about the form, so again, that was our use case that we were providing different kind of clusters. So you can create AWS, EKS, Azure and local cluster also. So you need to specify, okay, what kind of cluster I want, but that is totally customizable. So you can just set some default. So there was a lot of data which we have not even asked it, but at the backend, there is a lot of data like the RBAC thing, which even if the developer has the access to that resource or not, those we are checking at the backend. So yeah, we are doing that. And that is totally customizable. You can just set some default values for a team and then deploy it on the Backstage. Those default values get processed by Copier and it creates a template for you. So that is totally feasible. Thank you.
I'll go next. First of all, I would like to mention Farhaan and Rakesh, good job on uploading PowerPoint in advance. It really set the context right and you know what are you going to see. My question is not about the use case or architecture that you showed. I saw you are using Renovate bot. So I just want to understand how do you fit in this use case, that Renovate bot?
Okay, yeah, Rakesh.
So the host system, what we are creating, we will release the tags on weekly basis or a monthly basis based on our requirement from client. So let's say I have created a host cluster.git. The new feature which is coming from the client, that should be automatically raised in MR to the developer what he created. So we are using the Renovate bot for that.
Okay, so fetching the latest version of the application, you're using Renovate bot. Yeah.
Yeah.
Okay. Okay. Thank you.
Yeah. Just to add on that, so basically, as we are using Copier, so it will be a project template which will have the application code, right? So then a developer who has created a branch might forget to pull the latest changes. So for that reason, we have the Renovate bot. As soon as you release the new version of your main template, the Renovate checks that, okay, there is a new version. It just raises an MR. Like you can do many things with the Renovate, but we are using just to raise an MR for that. And the developer can verify, should I merge this change now or no? Should I first test my changes, later merge it, and then test again? So that is, just wanted to add on that. Yeah, we have a question.
So I have a question related to Carpenter. So are you using Carpenter just for the cloud or are you using for the on-premise provisioning too? And how your experience about provisioning? So is it working fine? And my second question is related to FluxCD. So currently most of teams choose the Argo CD.
Yeah.
What impress you to choose the FluxCD or what kind of problem it was solving that you doesn't found in the Argo CD?
cool. So I'm surprised why this question is coming this much late. I was thinking somebody will definitely ask why use Flux, why not Argo CD, right? So up to answer that, when we were developing this solution, we saw that Flux had a really easy learning curve rather than Argo CD. And at that time also, we didn't really needed a user interface of seeing these GitOps-based approaches, right? So we just wanted that, okay, I need a GitOps operator which can just fetch the changes and commit it, and it had different components. So it had source controller, customization controller, and different kind of component separated out in different controllers. So you can also control that, the notification which you want to send to Slack or Teams, right? So you can customize those also. So there were these features which led us to use FluxCD rather than Argo. But as I said, this is just a blueprint. So you can definitely remove Flux, add Argo CD, change the file system. You can create the application instead of Git repositories, and then it will work out of the box. So we are just trying to give a blueprint. We are very happy if you can just choose the alternative version, whichever suits your needs. And regarding the first question about the Carpenter, yes, we are currently only using it for the AWS infrastructure, because the host system which I showed you, the admin which had created it, it is based on it is an EKS cluster, and we are using Carpenter for that. We have also seen that it has the Azure support, so we have not yet explored it out, but yeah, that is definitely in pipeline. Plus the EKS auto mode has now been a competition for Carpenter, so yeah, we'll have to explore that also. But yeah, I hope you answered. Okay, cool. Okay, yeah, sure, please go ahead.
Hi Farhaan, hi Rakesh. You mentioned about cost saving when we skip using the shared resources or cluster and have feature specific resources, right? So can you share some insights on what was the cost saving in terms of maybe percentage or in absolute values if possible?
Yeah, so earlier when we were deploying this through the whole Terraform and the GitLab pipelines, we used to create a separate EKS cluster for each of this when we were testing this out, right? And then it used to add up on the AWS cloud bill for us, because you have a separate EKS cluster, which you cannot even turn off. Like you have to have a separate script to just turn it off on the weekends, right? You cannot just turn off, you can delete the node group, you can't turn off the control plane. You have to build it again the next day when you are coming back on Monday, right? So that was what it was adding us for the cloud bill. And with vCluster, what we saw was that it is very quick. So as it's namespace based, so all it has to do is just delete the namespace. We faced some issues while deleting the ingress controller and all those things, because the ingress controller was also creating the load balance in the cloud. So it will take some time and adjustment. That's why we used Helm hooks to delete those things. But yeah, the deletion was very quick, and we also had the custom logic to delete the unnecessary vClusters which were running on the cluster. So it had saved quite a lot of money for us. I don't have exact numbers, sorry for that, but yeah, this is what we have experience in that.
Hi, Farhaan. So the vCluster controller that you are using, is it an open source vCluster controller or any enterprise?
No, we are using the open source one.
Okay.
Yeah. Just the Helm chart of the vCluster, modified the Helm chart according to our need, so that if there is a ML workload, the node group should be created of an ML type, and then it sends the request to Carpenter to create the ML nodes. If some workload needs GPU, we have also attached the toleration and taints on the vCluster itself. So it requests that, okay, I need a GPU type of node. So when it goes to the cluster, the Carpenter sees that, okay, there is none of the node is accepting this. Why? Because it needs a GPU type of node. So Carpenter will provision that for you. So it's all open source, yeah.
So you also do vCluster level infra isolation, like attaching a node class for every vCluster, or the infra is pretty much shared?
No, we are doing the separation out of it also, because the main pod of the vCluster, so each vCluster will come up with its own pod and the code in this pod, right? So we are separating that out, because what we had observed that if that is coming on the same nodes as others, Carpenter was causing us an issue, because Carpenter can't delete the vCluster, the main vCluster controller pod itself in the beginning. It has to delete the Flux has to delete all other resources, then only the main vCluster pod should be deleted. So that was the reason we have separated out the vCluster pod. So we have a separate node which will just host the vCluster pod, and we have separate node for the workload which will be coming part for the vCluster. So that was the separation we have done.
So any tools you build to monitor the cost of independent vClusters?
We were using KubeCost. So KubeCost we have implemented and we have our in our tech stack. It gives us the different cost and optimization also what we can do. So we are using KubeCost for that. Yeah.
Thanks.
Thank you.
Hi, this is Kavita. In,
Sorry. Yeah, sure. Please go ahead.
so, in the, for every feature branch, you are creating this environment, right? So, an environment, it's not just like pods only. Other shared resources like Redis or database, any other things that we require for that environment. How was that like considered when you create environments for feature branch?
So when using these databases, it's all about the customization you can do with these things, right? So for us, the requirement for us was to just have a Kubernetes cluster, right? And then it was upon the code which the developer was pushing, what it is trying to create. So we have, as I said, we are using kubevela. So we have kubevela packages to spin up the databases also. So inside the vCluster itself, for that specific use case, we can spin up RDS, Redis database also. We can have Postgres also there. And it goes away as soon as you have destroyed the branch. So FluxCD sees that. And as it was part of that vCluster itself, it was just that namespace bound. It was not being shared anywhere. It gets deleted very easily.
And how much time it used to take, including database and other resources?
To delete, you're asking, right?
No, provisioning. Provisioning.
Provisioning, yeah. So the cluster itself will take less than 2 minutes, but the workload will take time. So because they have to come up in specific order also, right? The application should come up after the database. So that we have achieved through kubevela step function. So it waits for the database to come up. It checks the health check of that. It probes it, and then only the application, it says the application to come up. So the actual application might take time based on your code, but the vCluster, or you can say how fast I can access the vCluster, that is under 2 minutes. So as soon as the vCluster, you are having the connection, you can do kubectl, you can do whatever you want with that.
Okay, thank you.
How long it took for you to finish this project from ideation to what do you have right now?
So from idea, I will say more than 6 months to bring it all together, because we had to do a lot of POC to assess different kind of solution. For example, Argo CD versus Flux, and we have a lot of other tools which are working behind the scenes. So it took most of the time went into assessing which will suit our needs best. But once we had the tech stack defined, we were able to build it pretty fast. Yeah.
Hi, Farhaan. Here. Yeah, I have two questions. Have you evaluated AWS Harmonix plugin? AWS provide everything out of box. It's a Backstage plugin, and it does everything for you, whatever you have just showcased. Second question is, what's the scale of this? As in, you said you don't overwhelm the Backstage showcasing all the Kubernetes instances and ports, right? But Backstage does offer that plugin as well to showcase all that and become a single stop shop. So these two questions, and if you start scaling to the level, like to the enterprise level, to the like 2,000 and 3,000 cluster, have you evaluated that kind of a scale, or is it, what scale are you working on?
Cool. Starting with the scale, right? So this solution which we have is, right, what we have developed is currently hosting around 100 cluster, which we have seen. Plus, but what we have also observed with other teams is that they were hosting around 2,000 vClusters on a single host cluster. So we have observed that. That's why we chose vCluster to be as our ephemeral provisioner. So we have seen that as well. And coming to the plugin part, so here we had tried to leverage the open source plus free open source projects as much as possible. So and using any of these tools won't cost you anything, right? It's just the process power which will cost you. So we have not yet explored that, but thanks for suggestion. We can explore that.
Sure, thank you.
There was one more question I forgot. Sorry.
Hello.
Yeah.
You already talked about FluxCD, but I have a question. In one of your answers, you told you consider Argo CD also in your tech stack. So why what is the difference between the Argo CD versus the Flux CD, and why what Argo CD is not capable of helping in this solution?
Yeah, so I won't say Argo City is not capable of anything. Our choosing criteria was the learning curve. So we found Flux CD was very easy to adopt. So that's the reason we had adopted it. And it was very initial stages for us also. So we were a bunch of new developers just figuring out okay, which tech stack to use. So at that POC, we have also found that very easy to learn. And we have different controllers for all these things. So just for the Git, you have the source controller. For a customized, you have a different customized controller. And for the images which you are pushing, so the auto image update, that is also one control feature which we are using, which was not there in Argo CD. So we are heavily using that also in our solution. So that was the reason we used. And we didn't need a UI at that point of time. But again, I will reiterate, this is just a blueprint. You can switch any of the tools. It's very easy. You just remove FluxCD, put Argo CD, it should work out of the box for you. You just have to create the application file based on your requirement.
Yeah, thanks for that. I have one more question. In the entire version, you mentioned minimum 6 to 8 months you took it to the finalize or come up with this solution, right? What are the key challenges you faced in this journey? How you overcome those challenges?
Yeah, so as we mentioned in our slide, we had the challenges one, right? So that the main challenges was the deletion part, I would say, like the day 3 operation where you have to delete the resources when the testing is complete. So that is the most time consuming or most difficult for us was because creation is easy. You wait for database to come up, you wait for application to come, and then application can come up. But while deleting it, you have to delete the application, and once you have said to the system that this is steps you have to follow while creating, we didn't find an easy way to tell it that you have to reverse this when you are deleting. There was no easy way out of this. So most of the time what was happening is some external resources like load balancer or the RDS instances which was created in AWS was just left dangling because Flux was just deleting the vCluster and the Flux, even the Kubernetes did not even know about that. I had created something out there and I should have to delete it. So for that, we have to implement some custom logic that has to wait. The whole flow has to wait so that the external resources are deleted and then only it has to go to the next step. So that was, I think, the most challenging part for us when we did this.
Yeah, Rakesh and Farhaan here.
Yeah.
Yeah. So couple of questions, so just wanted to understand, have you tried integrating with any monitoring to verify the cluster usage and other things?
Yeah, so yeah, as we have not showcased as this part, so the tool, the code base which we have is also having Grafana and Prometheus at the backend, which shows the whole usage of this. And as I mentioned earlier, we have KubeCost also incorporated in the whole solution. So you get the billing of your AWS and the suggestion from KubeCost that where you can say which type of instance you can create. So that is integrated. We have just not showcased in this solution, but there are a lot of components that you can integrate any of them in this blueprint. As I said, this is just a blueprint. You can add any much more components in that. Yeah.
So, and another thing is, how are you minimizing the ephemeral instance? Like some applications need very low CPU and RAM and some may need high, right? So how the configuration are you being provided from this blueprint?
So that's what, when you're filling the form in the Backstage, so, and when the administrator had created this host cluster for the whole team. So there you can restrict like what kind of node should come up because the admin will know that my application would need these kind of workload. My application won't need a GPU workload, right? So you can, the administrator is controlling at that level. At the host cluster level itself, you are defining what kind of instances can come up. In the Carpenter also, you can define what kind of a node group it should create, what kind of instance, M5, T3, all those things you are, it's being handled at the host level itself.
Okay, yeah. And how about the secrets? We'll have them in the Backstage itself?
Yeah, maybe Rakesh.
No, we are using external secrets. We are copying the secrets from host to vCluster, wherever it is, the requirement is.
Okay, yeah. Thank you.
I have a question, okay?
Yeah.
So what are the sync strategies and the secret isolation strategies where you are, what you are actually using when you are actually promoting those changes from development environment to the other environments? Suppose a developer has created the multiple applications and it's using a different secrets. And in production, those secrets will be the different, right? how are you actually promoting those secrets and the isolations? How are you actually doing that?
So we have this automation in place. Like this environment is a production-like environment also. Developer does not need to create their own secret. Because this is a vCluster, we are copying the secret from the host itself. So the external secret operator will, the host system, you will have your all the secrets present there, which is acting as your production cluster also. So there all your secrets will be present. The external secret operator just copies it from the host into the vCluster. Developer does not have to provide their own secrets in that.
Okay, so if you are using an external secret, so you must be providing the authentication for the other providers where you, the secret needs to be authenticated, the provider operator needs to be authenticated.
Yeah,
So how are you actually integrating that? Is it a part of that host.git or is it a part of that?
That is the part
vCluster.git?
of the host cluster which is getting created.
Okay. What if the developer wants to use another operator which is not part of your external secrets operator? How are you actually going to do that?
Then they contract the infra team to implement that feature. But yeah, that is the only solution. Like we have to implement that if they have some third party. But the reason being, we are giving you this solution as for the testing phase itself. So it is not for the development of the infrastructure, the product, right? It's just for the testing. So you would have already developed. So you have already used the existing providers which is there in your product. And if you want to test, definitely you can customize this. You can build another product out of it where you can do the development also.
Okay. So suppose the external authentication, like external authentication is happening on the key clock or on the Azure Key Vault or some other identity provider. If all the developers will log in into the same Key Vault or log in into the same secret manager and create their own secrets, how are you actually going to do the secret isolation in that? Per development team, it should have a different secret. How are you actually assigning those roles and how are you actually managing those?
So that is what the separation comes here, where the admin was creating the host cluster, right? So that is a separate instance for a different team itself.
Host cluster, the vCluster is a part of the, once the secret has been created, right? That needs to be synced into the vCluster.
Yeah.
That is a different story. That secret isolation is happening, but how are you actually maintaining in the main identity provider where the secret needs to be created?
That secret is itself being maintained in the host cluster, right? So your team will just have their own host cluster. That team won't be connecting with, having a conflict with another team to create the host cluster. So the administrator of your team will create the host cluster first. There you will be hosting all your secret provider and maintaining all the secrets in that cluster itself. So you don't have the conflict with other teams using it.
Thank you.
Okay.
Yeah. Yeah, thank you for the insights. Yeah, here.
Yeah.
Okay. My question might be related to the previous questions, like how you are managing the multi-tenancy. Like once the admin creates the domains, right? How you make sure like they land into their tenant and they can see only that their domain, right? So how you achieve basically the multi-tenancy or RBAC part of it?
Yeah, right.
We are using the Backstage RBAC feature.
Okay, that which is called system, like?
We are filtering out the users based on what they have in the IDP. From the IDP, we are fetching the information, we are filtering, and also we have this catalog file. In the catalog file, we'll also have the group. Based on the group, we are doing that.
Okay, thank you.
I think if no more question. Yep. Thank you, everyone. Thank you for joining and thank you for the nice question. Please, if you have any feedbacks, please feel free to share.
Thank you.